The moon is slowly drifting away from Earth. Tonight, the moon hangs in the sky exactly where it has always seemed to be. It looks fixed and eternal, a silent companion that has watched over our planet for billions of years. But the moon is not standing still. Very slowly and very quietly, it is leaving us. Every single year, the moon drifts nearly 4 centimeters farther from the Earth. That is close to the speed at which your own fingernails grow, an almost invisible retreat. It sounds far too small to matter, and far too small to ever notice. Yet we can measure it with astonishing precision. The proof for this was left behind on the moon itself more than 50 years ago. When astronauts first walked on the lunar surface, they set down small panels covered in mirrors. Those mirrors still sit there today, silently facing the Earth across the emptiness of space. From observatories on the ground, scientists fire a pulse of laser light straight up at them. The light races to the moon, strikes the mirrors, and bounces all the way back to where it began. By timing that round trip down to a tiny fraction of a second, they measure the distance to within a few centimeters. Year after year, the answer comes back the same. The gap between us is quietly, steadily widening. So what could possibly push an object as vast as the moon away from us? The answer is written in the sea. The moon's gravity reaches across space and gently tugs on the Earth's ocean. It pulls the water into a slight bulge, a swelling of the sea that follows the moon across the sky. This is the tide, the daily rise and fall that has shaped our coastlines for as long as there have been shores. But here is the crucial part. The Earth spins far faster than the moon travels around it. As our planet turns beneath the ocean, it drags that watery bulge forward, a little ahead of the moon. Now the bulge is slightly out of place, sitting just in front of where the moon actually is. And that displaced water has its own gravity, gently pulling the moon forward along its orbit. That constant forward tug feeds a tiny bit of extra energy into the moon's motion. The more energy the moon gains, the wider its orbit grows, carrying it a little farther out each year. But energy is never created from nothing. Every push the moon receives, the Earth itself must pay for. As the moon pulls on the bulge pulls back on the Earth, dragging against our planet's spin. Like a brake pressed ever so softly, it is slowing the Earth's rotation, a fraction more with every century. So the two worlds are locked in a slow exchange. The Earth loses its spin, and the moon gains its distance. This means our days are quietly growing longer by a couple of thousandths of a second each century. It is far too gradual to ever feel. But stretch it across the deep history of our planet, and it changes everything. Run the clock backwards, and the Earth spins faster, while the moon draws closer and looms larger in the sky. Hundreds of millions of years ago, a single day here did not last 24 hours. Grew in ancient seas, a day may have been only 21 or 22 hours long. Remarkably, those corals kept a record of it in the fine growth lines laid down on their skeleton. By counting the daily and yearly bands, scientists found that ancient years held far more days than ours do now. In the age of the dinosaurs, the Earth turned quicker still, packing extra days into every single year. Go back far enough to the Earth's violent youth, and a single day may have rushed by in only a handful of hours. Back then, the moon was a giant, hanging enormous and close above a young, fast, restless world. Everything we think of as steady, the length of a day, the rhythm of the tides, has been slowly shifting all along. And if the moon is still moving away, it points us toward a strange and distant future. For now, We happen to live in a rare and lucky moment in the history of the sky. By pure coincidence, the moon and the sun appear almost exactly the same size when we look up from Earth. That is why, during a total solar eclipse, the moon can slide perfectly across the sun and hide it completely. It covers the blazing disk and reveals the sun's ghostly outer glow for a few breathtaking minutes. But that perfect fit is only temporary. As the moon retreats, it appears a tiny bit smaller each year. In the far future, it will be too small to ever cover the whole of the sun. The last perfect total eclipse will one day come and go, and after it, they will never happen again. The moon's retreat will not go on forever, though. In time, it must slowly ease toward a halt. As the Earth's spin keeps slowing, our day will stretch out longer and longer still. Eventually, a single day would last not hours, but weeks, matching the time the moon takes to circle us once. If that ever came to pass, the Earth and moon would face each other forever, each frozen in the other's sky. But it is all so slow that it may never truly arrive. Long before it could, the aging sun will swell and reshape both worlds. And so the moon you see tonight is not quite the same moon your distant ancestors gazed upon. It once hung closer and larger, over shorter days and faster seas, and it will keep drifting long after we are gone. Nothing in the sky is ever truly fixed. Even the moon is on a journey, one gentle centimeter at a time. So the next time you look up, remember you are seeing it at a single fleeting moment on a voyage billions of years long. Follow Worth Knowing for more things worth knowing.